There we go. All right. Take it away, Ryan.
All right. Awesome. Thank you. Thanks for coming, everyone. Good to catch up. So a few highlights. Oh, I'm missing one, but I'll get to it. First of all, there's been some discussion in the community about new design and spec updates and things like that. Dan went ahead and took a lot of that feedback and put it into an issue template and wrote up some documentation on how we should be, moving forward with design docs and spec updates and all of that. So thanks, Dan. I think what we'll do is we'll try and follow that that procedure and, basically try and get that rolling and iterate as we move forward on what we need to do differently, if anything. I also think, JB, didn't you volunteer to go and sort of backfill the other design docs and proposals? That'll be really good to get out there so that we have just that big list of things. So thank you both for working on that. The next thing I want to highlight is the support for manifest encryption went in, which is pretty awesome. So we now have the ability to read and write encrypted manifests. And the next thing on the encryption side that's going in is basically something that ties it all together, that lets you actually set encryption settings and inject a KMS client and things like that, so that you can go use the native file encryption for Parquet, encryption for Avro files, encryption for Avro manifests and manifest lists, and all of those things. So really great to see such progress on the encryption side. It's been a long road, and so thank you for I don't know if you meant to paste that there, but okay. So yeah, thank you guys for working hard on the encryption stuff. Another thing, Anton came through and fixed function pushdown for row level commands in Spark. Basically, we were previously looking for, I think, binary operators that had an expression that involved a system function for pushdown. And Anton just added a whole bunch more cases and sort of refactored that code so that we get the system function pushdown for things like merge and update commands. So that is awesome. And lastly, I want to highlight that a new contributor, Himadri, I didn't recognize the name, but came through and added support for multiple output, sorry, not multiple output specs, but basically output spec selection in rewrite data files. So if you want to take a whole bunch of data and write it into an older partition spec when you're producing data for for rewrite data files, you can now do that. So that is really nice to have in. So thank you for that new contribution. Really great. And the last one that I have under releases but not under highlights is that 1.5.0 was released after, I think, what was it, 6 RCs. So thank you to Ajantha and Edward for working on that and getting so many RCs rolled and out there. So really great to have that done with Vue support. Peter, did you want to say something?
No, I just wanted to congratulate, but find the wrong button.
Okay. Yeah, awesome to have 1.5.0 out. We should probably start thinking about what's going to go into 1.6. And I think there's talk of some things that we want to get into 1.5.1. So Dan, did you want to talk about 1.5.1 items?
I think there were just a couple minor ones. I'm not sure that we're even sure yet that we need a 1.5.1. One of the ones is a discussion item that we have down below, which is around schema behavior with time travel reads and refs. We can dig into that now, or we can wait until the discussion section. And I think that there was one other that came up. I believe Ajantha mentioned or found that on the Trino side, they ran into an issue where we're actually issuing an extra head request in the S3 file IO. So we're adding a lot of unnecessary requests where we already have the length just to go and fetch the length. So that may be a reason to do a 151, but it's not a huge issue. So I think it probably hinges more on this question about the schema behaviors with branches.
Yeah, so I think the extra head request we've actually solved on the Trino side. So if we do a release, I would definitely put it in there, but I don't think I would do a 151 just to get that out, because there is a workaround on the client side. Plus, I think all of our actually, no, I take that back. All of our S3 file IOs will continue to do an extra head request, but I don't know that it's that big a deal. So, JB, what did you want to add?
Yeah, I don't know if it's a 151 or 16, but we're gonna release a new Arrow version that include a couple of CV updates and fixes. So we'll have to upgrade Arrow 16. So it's going to be a 16.00, and it includes Arrow 112 that I'm pushing right now. That includes 2 CVE fixes. So not urgency, nothing major for us, but we'll have to include in 1.6 or 151. And on the other hand, then I'm also checking about an issue potentially with view support on JDBC catalog. So I'm investigating potentially issue, but no clue for now. But yeah, okay. Arrow, definitely we will need to upgrade at some point.
Okay, yeah, I think on that, usually we don't like to do major upgrades of dependencies in patch releases. So I think that would be a 1.6 kind of thing, unless there were a patch release that fixed those CVEs in the Arrow version, the major Arrow version that we're currently using.
Yeah. Actually, Arrow, I'm discussing with them because they are using major version, even if it's not actually a major version. So that's something that probably we should improve at Arrow. I mean, it should be a 15 something release, not a 16, because there are no breaking change, no major updates there. But anyway, that's a different story.
Yeah. All right. That sounds good. There was also talk of 0.6.1 on the Iceberg side. Paco, do you want to talk about that, or who suggested that? Was that?
It was Hona, but I don't think he's on the call today. Yeah, we had like a couple of small patches that we want to release. We're actually preparing the branch to cherry pick some of these releases back to the 0.6 branch. I think he targeted to start a release like end of this week. So if you have anything, please make sure to ping him or add it to the milestone, and we can make sure that's included into the release.
Okay, awesome. And what was the 544 one? It was, it failed to create version 1 table with non-empty partition spec and sort order. I guess it's just compatibility, something.
Yeah, that's compatibility, and we have a couple of more states as well. For example, with Spark before 1.5, you could not have like an empty current snapshot ID. It had to be like -1. So these are the kind of patches that we want to bring back.
Yes. So I'm familiar with that. So we were actually not writing the current snapshot ID.
So if you create like a new table, you don't have any snapshots, I don't think you can read it with Spark. It will give an error.
Yeah.
And if you write and it has like a valid snapshot ID, then everything is okay. You can set like a flag to bring back to like this legacy behavior and just write like a -1. It's like
I think the underlying problem is actually that the Java library doesn't adhere to the spec, in that like the snapshot ID is actually required by the Java library, even though it's optional in the spec.
It's optional in the spec? I thought it was required in the spec.
It's optional. So you can like creating a table without any snapshot is fine. Java sets it to -1 and requires that it's set. And so,
that was a bad decision on my part years ago.
Still haunting us.
That will haunt us forever now, because I don't know how you get backwards compatible at this point. So
Yeah, I don't know.
Yeah.
So yeah, okay, cool. Let me check out the spec because I really thought that it was required in the spec. We should probably do some investigation to make sure that didn't accidentally change, and document and make sure that like we know what that behavior is. Okay, awesome. Well, yeah. So keep an eye out for those things. If you have anything, I don't know that we have a 1.6.0 milestone, but we can start creating those and dropping things in there. All right. So in discussion, I think the first thing I wanted to cover was just have Dan say a little something about the new spec and design proposal process, so that everyone is familiar here.
Yeah, sure.
Yeah.
So just to catch everybody up on what's going on with the spec and proposal, there's been a long-standing issue where it's very hard for people to find what kind of discussions are going on in the community. You either have to search through the dev list. Sometimes the subject for the announcement has discussed, sometimes it doesn't. And I think just people are getting more and more interested about what is the roadmap, future, what kind of planning is going on in the Iceberg community. So what we wanted to do is get to some very low process way of being able to track these things that also doesn't require us having to go and constantly update the website. So what the proposal is to create an issue template. It's a little confusing because there's actually two different issue templates for improvements. One is an Iceberg improvement proposal, and that one is clearly described as for spec changes. You can see it if you go to the new issue templates or you try and create a new issue. And it's largely following the process that we've used for a long time, which is create a Google Doc initially so that people can comment and we can kind of iterate quickly. It's very hard to iterate on a GitHub issue just because the comments get intermixed and anything that you put in the description, it's hard to keep that up to date or comment on specific sections of it. So I think we'd still prefer Google Docs, but always open to alternatives if there's something better out there. There's a place to link to the Google Doc from the issue template. And then what we want to do is that issue template will also automatically apply the label proposal to that issue. So then from the website, what we can do is we can actually just link off to the actual search within GitHub of proposals. And anybody coming in can then see like what is under discussion, what is potentially on the roadmap. We'd also like to do that for things like releases and milestones. We're tracking those to some extent across various projects. I know we do it for the Java project and the Python one. I don't know if Rust is to a point where they're starting to use milestones or anything to track like the actual release numbers. But I think that by doing that, we alleviate some of the challenge of like keeping the website up to date, and we can just link off to the GitHub issues and milestones. So that's largely the state of it. I think Jan has done the very first one, which is the latest materialized view discussion. That one was a very complicated one, so I really appreciate that he went and did that. If anybody else has discussions out there, I think Drew, you may have one, Rahil. If you could go back and just create issues and fill out that template just so we get the label applied and we can start linking off from the website, that would be great.
Awesome. Well, thank you. Any questions or discussion on that, or can we move on? All right, let's move on. So the next thing I think that is good to discuss, and I'm glad to see Rahil and Drew here, is we've been thinking about how, for context, when we add new things to the REST protocol, how do we want to add those as new capabilities, and how do we want to handle compatibility? So we ran into this in a couple different areas with views, where if you're using a REST catalog and it doesn't support views because views just came out, you get some weird behavior in certain cases. And so what we had to do for things like renaming a table that is actually a view, what would happen was we added to rename table, hey, check whether this identifier exists as a view. Only we don't know if the catalog supports views. And so you might have that blow up with any number of exceptions. It might be a 404. I don't know what you're talking about on that route. It might be a 401 or a 403. Like, hey, you don't have access to this because we don't think the route exists. It might be a 400. It might be a 500. It might be, like some weird 500 that says like unsupported operation. So we basically had to add this try catch in the places where you're trying to see if a view exists that accepts basically any REST exception and says, hey, I don't think that view exists because I got a REST exception, which is not a good behavior to have. So what we wanted to do was start thinking about this and get this sort of cleaned up now, because we have the new features like the append support and the server-side planning support that are coming in. And I think we want to know, if a service supports those or not, basically ahead of time. So the proposal that Edward put together is basically to have capabilities sent back as part of the config route for what the service actually supports. Edward, do you want to go into a bit more detail on that?
Yeah, sure. So yeah, basically the config endpoint would return a capabilities field, essentially a list of capabilities the server supports. And so the idea is like in the Open API spec, we would tag the endpoints with that capability, so that from the Open API perspective, we know, those and those endpoints are required to support views. Those and those endpoints are required to support, feature X, Y, and Z. And once clients can read the capabilities, they can, they will have checks in place to say, oh, if the server doesn't support this capability, then I'm not going to call this endpoint because it most likely doesn't exist or is not supported. So that's the basic idea behind this. JB?
Yeah, Ed, is it something like an endpoint that return the capabilities, or is it more like something like a tag on the Open API specification?
So in Open API, it's just a tag for us to group endpoints together. At the endpoint level, it's the config endpoint that returns, just another field where a server can send back a list of strings and, therefore tell the client, look, I'm supporting those and those features, and you're okay to call those endpoints that are, bound to those features. That's the whole idea. Yeah.
Okay, sounds good. Yeah.
Yeah, I don't think it's too controversial, but I definitely wanted to mention it because, like, I think we're very, very close to getting the plan and pre-plan endpoints in there, and we'll want to make sure those are covered by capabilities. So I think this kind of blocks getting additional things in. The other thing is that we were discussing this, like Edward and Dan and I, and I was saying that I don't think that pagination would be one of these capabilities because pagination already has its own set of compatibility requirements that have already gone in. So like, if you don't send a page token, then the service sends back all results. If you send back an empty page token, you're signaling that the client supports pagination, and that you can. So it's basically like pagination is a client-side support thing as well as a server-side support thing, and we've already handled like the compatibility issues there. So I don't think that needs to be a capability, but I think there's more discussion around whether plan and pre-plan need to be separate capabilities, or how to handle that. And I think that's pretty much the next step with the server-side planning. Okay, awesome. Well, let's move on. The next one, I'm also going to hand it over to Edward because it's schema behavior with time travel reads. And it's good to see Namratha here because I think you are the one that hit this in practice. And so Edward, do you want to talk through the problem and sort
Yep,
of
yep.
where we're at?
So a few things ago we discussed about what schema should be returned when you do stuff against a branch, and we decided that the schema that is going to be returned when you do something against a branch is the tables schema. That has the effect that when you now read or write against a branch, or like when you change the add or remove some columns on the main branch, and when you query data on a branch that previously was using a different schema, it doesn't show columns that were previously existing. Like, that's what users see. Like, it wouldn't show data for columns that existed at a certain point in time on that branch. And the other effect is, when you write data into a branch, because what we want to do is we use the tables schema to write data into the branch, because otherwise we have this weird situation where we read data from a branch, we use a different schema than when we write data to a branch, and it causes all sorts of confusion. So that's why I like the PR. It's 9131, which essentially changed which schema is being returned for branches. For tags, nothing changed. For tags, we always return the snapshots schema. And we discussed this with Dan earlier this week, that I think the long-term solution would be to track schema for branches.
I'm not sure about that.
Oh, yeah.
I think that that is one of the possible approaches.
Okay, yeah, one of the possible, yeah.
So the underlying issue is that, a lot of people have asked for being able to evolve schemas on branches, and that's not something that we can really do in the current spec. So in the future, we can look to addressing that, and one option would be to track the actual schema by branch. I think here the question is really more about what are the schema behaviors on branches and with time travel. The obvious one that we've kind of settled on is that if you're reading a tag, then you read based on the schema of the snapshot that is pointed to by that ref. So tags read with the schema. That's pretty clear. When it comes to a branch, if you're reading the branch, normally you want the table schema. The table schema is the latest. That's what you're going to read from. That's what you're going to write to. And that's what this PR fixed originally, was the fact that we used to be reading the snapshot schema when you read from a branch or tried to write into a branch. And that caused problems, because then once you wrote, it would switch that to the latest schema. And so you'd have this really weird behavior when working on branches, where you would see a prior schema until you wrote into the branch, and then you would see the current schema, because it was always based off of whatever the snapshot was that was pointed to by that branch. So the PR fixed that, so we always reflect the table schema. But then the behavior change that happened was when we do time travel reads now, we're using the current table schema for the time travel reads. And so what we want to do is, when you're referencing a branch, whether it's main or anything else, you use the schema ID for the snapshot that you're reading at if you're reading a specific snapshot. So time travel reflects what the schema was at that time. Any current operations reflect the current table schema. Does that make sense?
Yeah, so if you're just reading from the head of a branch, you get the current schema for the branch, which is the current table schema, because we haven't built a way to distinguish that. And if you are time traveling to a specific version of the branch, you get that that snapshots schema. I think that makes sense.
Because we'd actually, I think that part of the reason that we ended up in the situation that we were fixing is because of the earlier decision that when you time travel read, you actually want to see the snapshot of that particular, or the schema of that particular snapshot. Unfortunately, that carried forward to when you're reading the head of that branch, you were also seeing that particular snapshot, and that would deviate from the table schema when the schema was evolved, and that caused some weird issues.
So we just went too far with the fix and essentially changed the schema of the time travel. Okay. That seems like a pretty big regression and miss. on the branch schema. So is this something that we should get into a 151 patch release?
I think so. If it's relatively straightforward, like I don't know if we've really delved in to make sure that we can read as of snapshot ID. I think it's pretty straightforward. But Edward, unless you've taken the time to actually go and look at that yet.
Yeah, I mean, I looked a little bit into that. So what would happen if you actually say select stuff from table.branch X? Like, which schema should be returned? Is it
the branch schema?
No.
Sorry. The table schema. Branches. Well, I mean, it's the branch schema, but that has to be the same as the table schema.
That's what we have right now. When should we return the?
If you're time traveling to a specific snapshot on that branch. So this would be like version as of
on the branch
snapshot ID.
Yeah, okay, just snapshot ID. Yeah. That I think works, but I need to double check because that's not the issue that Namratha ran into.
I thought it was. Namratha, do you want to talk about the issue that you had?
Sure. So I ran into the issue when I queried by version as of the time travel query. That is when it returned like the old schema. It is supposed to return the branch schema.
Oh, well then the current behavior is the correct behavior. It actually should, if you time travel, you should get the version as of that snap.
Yeah, I think so, because that's the behavior that we want for main, and main should not behave differently than other branches. So I think that you want to use the schema that was current when that snapshot was created, when time traveling to a specific snapshot.
Correct. So yeah, when we query using version as of or a time or a branch, it should actually reference to the schema when the branch was created.
So I think you mean the snapshot that you're reading,
Sorry,
right?
Yeah, snapshot.
Okay. Yeah. The branch schema is actually the table schema at all times, because the branches can't have schemas that are different from the table schema. But what we can do is go to the schema at that point in time when the snapshot was created.
I also have one more concern here. So like if the schema keeps on changing and the snapshot doesn't progress, so if there are no writes on the table, then the old snapshot will still be pointing like to the old schema. So this there is no new snapshot pointing to the latest schema. So that is also one of the issue that will arise.
Well, so I think that is alleviated by the fact that the branch, if you're referencing just the branch without time traveling, then that is always the current table schema. So yeah, you always get the current table schema. Now we've talked about creating no-op snapshots to capture when the schema actually changes within the branch, within a branch, but I don't think we're quite there yet. I think there are very good arguments against that, because then any schema change would create a new snapshot across all branches, and that's a little weird.
And there's also, like, what we're actually defining here is what we expect the SQL behavior to be specifically within Spark, because from an API perspective, reading or writing to an Iceberg table can be done with any valid schema. So what we're saying here is, like, what is the behavior in Spark under certain conditions? You should really be able to read or write the table data with any valid schema. And I think the one that matters most here is just like, what do people expect from a SQL interface?
I mean, with write, that totally makes sense, Daniel. But with read, now we are saying that if the main branch changes, we are going to read with a totally different schema that might be that might not make sense for that given branch, right? Like that is where I am still trying to understand the rationale.
Are you talking in the case of reading from the head of a branch or reading from a time travel of the branch?
It's from the head of the branch. It's like
From the head of the
select star
branch.
from.
I'm just issuing a plain SQL statement, right?
Right.
And I did a select star on the branch. Let's say I got columns ABC, and somebody came in and changed my main branch to delete C and add D, so it's ABD. Now, if I just issue a plain SQL statement on my branch, I'm seeing ABD, right?
Yep.
And that is where, and to make matters worse, let's say that they actually have data in D, in column D, in the main branch. Here in the branch, I will have like a column which has all null values and a schema that basically doesn't make sense, right? Like I know data files actually point to that schema. So that is where
this comes down to the interpretation of schema and branches. And right now, Iceberg does not have a way for a branch to have a specific schema. So we can discuss adding that metadata, basically adding a schema ID to refs, actually to branch refs only. But I'm skeptical that is a good idea, because we need to go very deep into what the behavior is when you do this. So think of it this way. If you're using branches to fast forward, right? Or like, sorry. Yeah, so if you're using branches for certain purposes, then you want the columns added across branches to be the same. And if you're using branches for other purposes, you want them to be different. You're describing a situation in which you want the columns to be essentially different, and a branch has a different set of columns than another branch. But then when we go to reconcile or bring branches together, how do we know whether column D in branch 1 is the same as column D in branch 2? We need to decide what that behavior is, because this is an entirely new area. It's a big problem, and I think right now we want to determine like what should the time travel behavior be, and not necessarily crack open that problem. But I would love to have a proposal on the exact behavior of basically tracking schema by branch. I think that's the next step if you want to track schema by branch, is have a proposal for exactly how it works, and what the trade-off, understand what the trade-offs are, and sort of how we can defend the design of making a particular choice or another.
I just want to add on to that under the current model, like one of the problems is if you have a branch and you want to maintain the schema on that branch, since we're not tracking it anywhere, the only reference to that schema ID is in the snapshot that's the head of that branch. If you write into that branch, again, you end up using the table's schema at that point, and it ends up switching the actual schema for that branch as well. And we don't really have a concept of saying like, well, use the last snapshot's like schema ID to write the next snapshot so that we maintain the, so this just gets back to the fact that we're not tracking the schema IDs by branch. So it has to be at the table level. And that was actually the problem that we were having previously prior to Edward's 9131 was when you did that right, it would actually switch the schema on you, because it was looking at whatever the schema was on that that particular branch snapshot.
Yeah. I see. The main problem that we are facing is actually, since you brought that up, Daniel, like whatever Ryan like that you instilled, I would just want to reiterate that principle and make sure that is indeed what you are rooting for here, right? So at a principal level, for any mutations on a given branch, you don't want that branch to evolve its own schema. You want that to be aligned with main branch. That is the main reason why you guys are trying to align all branches with like schema modifications are possible only on the main branch, right? So schema going from there.
table itself has a schema and all branches have that schema. That's the current semantic, because we don't track the branch or the schema of branches separately.
Makes sense. Makes sense.
So I actually wonder if the confusion comes from the fact that there are two different ways to read data from a branch. One is the, select star from table version as of branch, which is a time travel query, versus select star from table.branch.name, which is reading from the head of the branch. And that
So
has
whatever syntax we use for passing the branch name, I think it's pretty clear when you're reading from a branch by name versus reading from a specific snapshot.
I just think we need to be crisp about what is the schema behavior across branches and main and for the table. And currently that is, there is, one current table schema, and that is used for all branches, including main.
Yep. Okay.
And one problem that comes up, right? Like even with this model is if your main branch, let's say, have snapshot S10 and schema ID 10. Now, if your schema ID progressed to 11, and at that point you created a branch, that branch would correspond to snapshot 10, but then your schema ID, just doesn't propagate to the branch.
Actually, now with 1.5, if you read from that branch, you will see the new schema.
Yeah.
So prior to 1.5, you would see the schema that was in the snapshot, 10 or whatever you said. But now with the 1.5 change, you will see the current table schema.
The problem is also that if another branch comes in, another schema change comes in, and S12 comes in, we will see S12 as well, right?
Yep.
On the branch.
Yeah. So again, all branches have the same schema as the table. If we want to change that, we can definitely discuss it. But I feel like we're kind of going around in circles around that point. Yeah. Today, we have no way of tracking schema by branch schema. So all branches have the same schema as the table. We can definitely discuss changing that. But like right now, I think we understand the right behavior for time travel. We understand the right behavior for branches, and we need to make sure that we like fix this bug for 151. And also, like, rather than going around in circles on the same issue, I'd love to get to Flink table maintenance, because Peter's been waiting very patiently for like 2 of these meetings.
Yes,
is that all right?
Yeah.
Okay, cool. And definitely like follow up with us, on the dev list and in the Slack, because we're definitely like interested in working with others to solve this problem. I don't think are going to solve it today. All right, Peter, off to you.
Thank you, guys. Actually, it was like 4 meetings now.
Sorry.
Okay, so previously my question was for the community that I'm planning to work on creating the Flink compaction and related stuff. No, I'm saying that I'm working on that currently, and I have some more or less working examples, but still I think I found most of the issues, but I would like to get some feedback on that. I will follow through the proposal stuff and everything you highlighted in the beginning of this meeting. But I just want to know that I want to tell you that the thing which so we had the issue with the Flink writes that we are writing continuously very small files, and checkpointing often means that we have plenty of small files. Also with the CDC, we have the equality deletes and positional deletes, which are littering the Iceberg table space and makes the reading of the table suboptimal. Let's say that's suboptimal. And the team for Spark did a very good job at creating a compaction for those. But there are several users out there who do not have access to a Spark cluster, so they cannot use the Spark compaction stuff. And we have customers asking for making sure that in a Flink job we can run these compaction jobs as well. So what I did, let me share. Is it possible to share the screen? Yeah.
It should be, yeah.
Entire screen. And I hope. But if
it doesn't let you all, it should pop something up for me. There you go.
There we go.
Okay. Can you see the screen though?
Yes.
Okay, cool. So I have two ways of running these maintenance jobs, maintenance tasks in head. One of them is putting the whole stuff in the after the committer in a Flink sync. So basically, after something is written to the Iceberg table, committed to the Iceberg table, we can run a scheduler, decide if we want to run the maintenance job, and then run the maintenance jobs in sequence. This is very useful when you have a single job writing to a single table, and you don't want to mess around anything else. Another way I would like to make sure that the compaction is working, to have a monitoring job, which is monitoring the table, fetching the data, fetching the new snapshot arriving to the table, and based on the scheduling capability, it will decide when to run these jobs. I would like to see if you have any other use cases which you have in your mind, which you are interested in to include, or this is enough for most of the use cases out there. Okay, Daniel.
Yeah. So my first question is, in terms of the maintenance operation, is that actually running as part of the Flink job itself, or it almost looked like there were kind of two options there. One, running as part of the Flink job. The other one running separately, but monitoring the table itself and running as a Flink job. Is that correct?
Yeah. So basically, there are two options here. One option is when you are so Flink Sync v2 has an option to provide post-commit topology for a sync. So if you move the Flink sync to this Sync v2 Flink sync, then we will be able to put the scheduling and everything after the commit. So we can run it in the same job, and we can schedule it there. But this task has a different usage pattern, resource usage pattern than really most of the Flink jobs. So probably you want to be able to separate those out if you don't have a very simple situation when you don't want we just want to have a simple job in one place. So another one is for scheduling in a different job or in the same job but the different topology.
Okay, because the reason I was wondering is like one of the challenges that I think is going to come up is like if you're writing lots of delete files, like when are you going to be able to actually execute the maintenance without having more Flink writes come in and kind of conflict with your delete rewrites that are happening?
Sorry.
And so I was just wondering, like, if it's all in the same workflow, is there kind of like a stop the world operation you can do periodically to say like, hey, we're going to actually stop the committer that's writing out so that you can do the maintenance without running into any sort of conflict?
Okay, so this is not the stop the world operation. Okay. This is running concurrently and trying to compact those files. And if you have only Flink writes, it's a little bit of easier things because Flink has equality deletes, which doesn't conflict with compactions. And Anton created the fix for the Flink positional deletes because Flink positional deletes only refer to a single file, so it's very easy to make sure that we have no conflicts there. So for Flink jobs, it is an easy stuff. If you have Spark writers as well with plenty of positional deletes, you still have a conflicts like you have conflicts with the Spark jobs as well.
So that kind of the conflict stuff kind of gets to where I was thinking. So to me, like, we've had people suggest basically the same thing a few times over the years. And I'm not sure that I agree necessarily with that sort of periodic, go figure out what we need to do type fix, because the Flink application already has all the information that it needs to run the compaction. So, right, like, say we have you know, files flowing in, and then we periodically compact those, and you know, we might have equality deletes and positional deletes flowing into the table as well. Then essentially, like, what we're saying is, hey, then this other thing wakes up and checks the state of the entire table, and then does some action planning on the entire table state to, you know, figure out what it needs to do. But we already had all of the data files and all of the delete files in the Flink application already. So to me, it seems like what we should do is emit those data and delete file metadatas just to a downstream stage and run compaction on those things. So imagine, like, everything that gets committed by the committer, all of those data and delete files get emitted to a downstream phase that keys by, you know, you add a key by with the partition spec, or, you know, partition tuple. You collect all of those files, and then once you accumulate enough, you know, data files, you apply the deletes and rewrite them. And then you also know, essentially, like, all of the deletes that you've applied in the sequence number, so you can resequence that new data file and commit it in a second, like, sort of asynchronous commit. So I really like this idea of the inline compaction. There are still some issues, because you need to make sure that there aren't additional position deletes against those data files. But that's actually a way easier check than going and reading a whole bunch of new table metadata and figuring out what to do. So, like, I kind of like that more streaming approach. I'm curious what you think, and why you were thinking this method rather than something like that.
Okay, so the basic thing is that you can have multiple things writing to a same table in a different job, and in this case you don't have the information at hand to compact everything. You can compact your stuff, but if there are concurrent writes, concurrent commits, then you will have to again check the table and see if what you can do and how you should do. Then you can make sure that the sequence numbers are correctly handled, and you cannot compact separately your stuff, but this whole stuff together.
I agree with you. I think you would have to check for new delete files, right? You would have to make sure that if you're compacting between sequence number 7 and number 10, you'd have to know about all the deletes that are applied between 7 and 10, right? So you'd have to read at least the delete manifests, but that should be much lighter weight. And then you're compacting, like, each Flink cluster is responsible for compacting its own data files, and you don't need to worry about, like, another cluster's data files.
And it's probably pretty straightforward for the most common case, where you're the one producing all the snapshots to be able to short circuit any complicated logic to go and find those deletes. Because if you've produced all the snapshots, like a typical Flink scenario where you just have one Flink job writing out one table or writing out multiple tables, it would be able to know that it produced all of those snapshots, and then wouldn't have to go and do any sort of checks for additional delete files or anything like that.
And I think everything downstream of this, like, if we were to look at how this Flink application is constructed, you basically have something that emits data files and delete files, right? Which can be the existing committer plus this additional logic to, like, go look for snapshots that it didn't produce and go run, you know, do this, or something that can periodically go and say, okay, I'm starting from this snapshot and I want to compact through this snapshot, and basically do the exact same work. Then you have the key by and sort of worker tasks. And then you once again bring that in and then do your replace commit in a committer. So like, I think that you can reuse nearly all of this and have like lighter weight, a lighter weight planning operation if you were to do that, or at least structure it that way.
My feeling is that this is solving one specific case, or probably it is the one which is which is happening quite often. But this is only one specific case when we have one single writer writing to one table, and if you start seeing cases when the tables are written by multiple cases, or you want to get rid of the equality delete files, because the way you describe the process, I think we are able to remove the positional delete files, but we will not be able to remove the equality delete files. We still have huge number of equality deletes if you have a CDC write in this case.
So that is true. You would be resequencing new data past the equality deletes that you have added, but you wouldn't necessarily be able to get rid of equality deletes entirely. So they would be cluttering up that planning operation. I think, I mean, to me, those seem like separate operations, but I could be convinced that way. It's a good point that you're not completely getting rid of those equality deletes. I guess it depends on the. Sorry, go ahead, Russell.
I was going to say that another question I had, I'm just kind of thinking about this a little right now, is if we're doing the serial process here where we're planning based on everything we did up to that point, is there a way we can handle carryover? So like say we do a compaction, but our compaction also outputs files that are small enough to require compaction on the next go around. Is that something that Flink can do?
That's not trivial in Flink. You basically there are no loopbacks. There you can write out some disk somewhere or have a Kafka queue put it there, right. but reading back it's a non-trivial stuff.
It's too bad, because that's also why we can't do like range partitioning and stuff like that.
Steven,
right. I unfortunately have to go, but I don't want to end this discussion for everybody. Thank you, Peter. I would love to see more detail on this, because I'm very excited about the Flink stuff. Moving and actually doing compaction. So.
Ryan, do you think we should set up a meeting outside of this, specifically around this topic, or do we instead of punting this to the next one?
I think I would leave it in Peter's hands to see how he wants to proceed. It sounds like, Peter, you're looking for feedback and discussion here. If you want further discussion and to sort of dig in, I would be happy to join, and I'm sure others would as well from the community. Just to make sure that we're designing this in a way that I think we get maximum benefit out of. Like I said, I think that you can feed what we build can be fed either continuously by a committer or by something that runs periodically, like you're talking about. And I think if we design this correctly, we can fit both use cases in there. So
I would also just call out, we should loop in Brian Keller as well. Brian has worked quite a bit on the Flink side and may have some thoughts too. So he's not here today, I don't think, but we could loop him into that discussion, and he might have some ideas.
Yeah. Okay, I will send out a letter to the list, and then we can continue.
Yeah, and Peter, if you have any questions, I can help. Also with scheduling stuff. I have a lot of the people's emails just to get everybody who's interested to join. But yeah, mailing lists will definitely be a good place to start.
Okay, cool.
Awesome.
Thank you.
Thanks.
Have a good day, everyone.
See y'all.